Hi, welcome to Software Testing from Scratch. My name is Richard Martin. This is Chapter 2, Common Phases of Testing, video number 2. So we've already covered 4 topics so far, and next we're going to cover phases, advantages and disadvantages, as well as all of the following testing types: unit, integration, system, regression, acceptance, alpha and beta, V-model, and agile. So, phase advantages / disadvantages. You may notice this slide is blank. That is intentional. Every phase will be suited to a particular job, and you're going to be the best person to know if a particular phase of testing is going to be suitable to you or not. We're going to come back to advantages and disadvantages in future topics when we have some more real-world scenarios, but hopefully when we go through these testing types and testing phases, you'll see exactly what I mean when I say a disadvantage for one particular test may not be a disadvantage for another particular test. We'll continue and hopefully that'll make more sense. Unit testing. Unit testing is a software testing method by which individual units of source code sets of one or more computer program modules together with associated control data, usage procedures and operating procedures are tested to determine if they are fit for use. Intuitively, one can view a unit as the smallest testable part of an application. You don't just build a car and test the entire car. Each component has to be tested individually. The tyres will be tested, the lights will be tested, even down to the injectors in the engine. If one of those parts was to fail, then it could have major results for the entire car itself, which is why unit testing is probably one of the most important types of testing when new components are going to be integrated into an existing system. You have to have that assurance that the particular unit that you're going to try and integrate will work with the existing code. Which brings us nicely onto integration testing. This is sometimes abbreviated as INT. It's the phase in software testing in which individual software modules are combined and tested as a group. Modules could be a particular unit, so multiple units together to be tested in a group. It occurs after unit testing, but before validation testing. Integration testing takes as its input modules that have been unit tested, groups them in larger aggregates. It applies tests defined in integration testing plan to those aggregates and delivers as an output the integrated system ready for system testing. So each of these particular testing types is a stepping stone right the way down to system testing, which is the final stage, if you will. Does everything work together? Again, brings us on nicely to system testing. System testing of software or hardware is testing conducted on a complete integrated system to evaluate the system's compliance with its specified requirements. System testing falls within the scope of BlackBox testing and as such should require no knowledge of the inner design of the code or the logic behind it. This is making sure that it does exactly what it says on the tin. As a rule, system testing takes as its input all of the integrated software components that have passed integration testing and also the software system itself integrated with any applicable hardware system. So not only does your software have to be tested, but you have to have the knowledge that the hardware it's designed to run on will work as well. So this is the full end-to-end system. Does your software work? Do your hardware drivers work? Does the hardware itself work? Now, regression testing. Regression testing is a type of testing that seeks to uncover new software bugs or regressions in existing functional and non-functional areas of a system after changes such as enhancements, patches or config changes have been made to them. Regression testing might take place after a particular new addition has been unit tested and then integration tested, and then the entire system has to be regression tested to make sure it hasn't caused any other issues. So basically the intent of regression testing is to ensure that changes such as those mentioned above have not introduced new faults. One of the main reasons for regression testing is to determine whether a change in a single part of the software or config affects other parts of the software. Say you were configuring a firewall system and you create a different access list or something like that. You should definitely do a full regression test to make sure that that particular access list doesn't conflict with any other workings of that firewall. Common methods of regression testing include rerunning previously completed test sets and checking whether the behavior of the application is as expected. It's testing that can be performed on a system efficiently. It has to be systematic, and it must select the minimum set of tests needed to adequately cover that particular change. It's probably going to be very time consuming if you need to run an entire system test for regression. Ideally, you need to focus your efforts on what has changed and try and prove in as little tests, but in the most effective way possible, that these changes haven't had an adverse effect on the entire system. Acceptance testing is conducted to determine if the requirements of a specification or contract are met. Software developers often distinguish acceptance testing by the system provider from acceptance testing by the customer, which is obviously the user or the client, prior to accepting transfer of ownership of the product. In the case of software, acceptance testing performed by the customer is known as user acceptance testing or UAT testing, site acceptance testing, or sometimes even field acceptance testing. It can take on many forms depending on the particular project, but at the end of the day, it all comes down to user acceptance testing. Do the users who are actually using the product accept that it works the way it does? It works the way it should do and the way it does, and also is it fit for purpose? Now we come on to alpha testing. It's simulated or actual operational testing by potential users or customers, or sometimes even a testing team, or even an independent test team. It's often performed for off-the-shelf software as a form of almost internal acceptance testing before the software goes into beta testing, which is the next phase. Beta testing comes after alpha testing, obviously. It can be considered a form of external user acceptance testing. This is where the software product will be placed in a situation in the field where maybe live customers are using it and it would be tested. Versions of the software known as beta versions are released to a limited audience outside of the programming team, or maybe even outside of the company sometimes. The software is released to groups of people so that further testing can ensure the product has few faults or bugs. Sometimes beta versions are made available even to the public, as I say, to increase feedback fields to a maximum number of future users. Ideally, the largest beta test you can have, the better. The more people you have outside your company that don't necessarily know how the product should really work, but are testing it anyway, is by far the best way to do things. Now we have particular testing models. As you can see, we have the V model here, which down one side matches user requirement models to operational system requirement models to integrated system, architecture models to subsystems, component design models to components, switches, hardware, data, etc. And unit design models to units, software, hardware, data, etc. again. So the development V model builds on the waterfall model by emphasizing verification and validation. The V model also takes the bottom half of the waterfall model and bends it upwards to the form of a V, so that activities on the right verify or validate work products of the activities on the left. More specifically than that, the left side of the V represents the analysis activities that decompose the user's needs into small, manageable pieces, while the right side of the V shows the corresponding synthesis activities that aggregate and test these pieces into a system that meets the user's needs. In this case, the left side of the V illustrates the analysis of ever more detailed executable models, whilst the right side would illustrate the corresponding incremental and iterative activities of the actual system. Now, the Agile model. Agile is an iterative and incremental model. This means that the tester should test each increment of code as soon as it's finished, which would mean lots of unit tests and not very many system tests. Iteration might be as short as 1 week or as long as a month. The team builds and tests a little bit of code to make sure it works perfectly, and then moves on to the next piece to be built, and so on and so forth. Each Lego brick is checked before it's placed on the final model. Programmers never really get ahead of the testers because the story isn't finished yet. Although they might have an idea of what's coming next, the actual bit of code which they need to test next wouldn't have been written until the previous one had already been signed off as working.